I'll start explaining the solution now. So essentially our question is Ted mistakenly wrote 2 to the power of m times 1 over 4096 as 2 times the nth root of 1 over 4096. So what is the sum of all real numbers m for which these two expressions have the same value? So essentially, it's asking what is the sum of all real numbers of this variable where these two expressions are equal. So to solve this, we're going to be using logarithms. Essentially, we want to keep these two equations equal. So first we can rewrite our equation into logarithmic form. So 2 to the power of n times the square root of 1 over 4096 has to equal to 2 times m, the nth root of 1 over 4096. So to rewrite this, we're just going to add log. We're gonna rewrite it as log 2 of 2 to the power of n. Log 2 to the power of n times 4096 to the power of negative 1 over 2. I'm also going to be using a fractional exponent rule to convert this to this. And on our other side of the equation, we're going to write the other expression as log 2 times 4096 power of 1 over m. Okay, so now that we've rewritten our equation, we can use the product rule, which I explained in my last lesson, to separate the two expressions and the stuff inside the brackets. So once we use the product rule, our equation would become log 2 to the power of n plus log 2 4096 to the power of 1 over 2. Okay, so that's one side. That's the first expression of our equation. So on the other side of our equation, we're going to be writing the expression as log 2 2 plus log 2 of 4096 to the power of 1 over m. Okay, so now that we've separated both of our expressions with the stuff inside of the brackets, we can start simplifying now. So Um, we can convert 4096 into exponential form first. And 4096 in exponential form is 2 to the power of 12. So this will become 2 to the power of 12. And this also 2 to the power of 12. So we can bring the exponents down, which would give us m to m minus 6 because 12, because this is now an exponential form, and you can't forget about this. So this 12 would actually become -6, which, and now on the other side, we have a 1 here because this is just 1. Gives us 1 minus 12 over m, because again, this is -1 over m. So now we can start simplifying, and the first thing we should do is isolate the variables on one side and the constants on the other side. So we can bring this over by adding another 12 over m, which would give us m plus 12 over m minus 6 equals 1. So now we want to move the 6 over here. So we can add a 6 to both sides to get m plus 12 over m equals 7. So now that we've isolated the variables and the constants to each of their respective sides, our next step is to get rid of this m, this denominator m. So the way we can do that is multiplying by m again. So we would get m squared plus 12 equals 7m. Now that we have 3 variables, this might look familiar to some of you guys because this is actually a quadratic equation. So we can rearrange it and bring the 7 over to get m squared minus 7m plus 12 equal to 0. Now this meets all of the requirements to be a quadratic equation, so we can just solve this using the quadratic formula. And then we get, one in factored form, we get m minus 3 times m minus 4 equal to 0. I'm just going to bring this over here, which means m equals to 3 or m equals to 4. And 3 plus 4 is equal to C7. So that's the solution to our first problem. You guys have like any questions? No questions? Okay. Next question then. Okay. Let me clear my screen. Okay, so here's our next question. I think this one's easier. I'll give you guys 3 minutes to do this. So I'll check back at 12:28. Okay, guys, it's been like around 3 minutes, so I think we can start. So our solution here. Okay, so our question is, suppose the 4 to the power of A equals 5, 5 to the power of B equals 6, 6 to the power of C equals 7, and 7 to the power of D equals 8. And it's asking what is all of these variable exponents multiplied together. So for our solution, we can, since we're solving using logarithms, we can rewrite these all into logarithms because they're all in exponential form right now. So essentially, we can write 4 to the power of A equals 5 as A equals log base 4 of 5. So we just converted from exponential form to logarithmic form. So we can do the same. We can do the same for all of the other exponents. So essentially B would become log base 5 of 6, C log 6 of 7, and D log 7 of 8. And as you guys know, I already taught in my last class how to convert from exponential form to logarithmic form and vice versa. So, and now that we've converted all of our exponents to logarithmic form, we also know that we can change the base formula. We can change the base by using this formula right here, as I taught in my last class. So we can rewrite all of the logs into the change of base formula and multiply them together. So essentially, we would have A times, I'm going to scroll down a little bit more. Okay, so essentially, we would have A times B times C times D equal to log 5 over log 4 times log log 6 over log 5 times log 7 over log 6 times log 8 over log 7. Okay, so now that we've written this into the change of base formula, we can start simplifying. So as you can see, there's a lot of duplicates here. So we can actually just cancel all of these out. So this log 5 is going, 6 is going, and log 7 is also going. Those are all canceled out, which gives us A times B times C times D as log 8 over log 4. So now that we have a singular expression, we can simplify even further. So A times B times C times D, we can convert log 8 into 3 times log 2. And we can convert log 4 to 2 log 2. And as you can see, like again, we have a duplicate here. So we cancel it, and A times B times C times D equal to 3/2, which is B. Okay, so do you guys have like any questions about this? No questions? Okay, then we'll just move on to the next question. So here we have our next question. So I'll give you guys like I'll give you guys like 3 minutes to do this again. So I'll check back in at like 12:37. Okay, guys, I think it's been like around 3 minutes. So I'm gonna start explaining the solution to this question. Um, okay, so essentially, our question is that there is a unique positive integer n such that log 2 times log base 2 of log 16 n equals to log 4 of log 4n. So it's asking, what is the sum of the digits of n? So since this is already in logarithmic form, there's no need for us to do any converting between exponential and logarithmic form. So we can first change the base using the form. We can first change the base of this equation using the formula log ABC equals to 1/b log AC. I taught this in my last class. So yeah. So we can convert everything to powers of 2. So our original equation here, log 16 and 4 of log 4n. So essentially this equation, we can start by converting the left side of our equation. So this is already base 2, so we don't have to do anything about that. But here we have 16. So this part would become log 2 to the power of 4. And on this side, this would become log 2 of 2. And inside the brackets on the right side of our equation would also become log 2 of 2. So yeah. So now that we've converted these, we can input them into this formula here, which would be log 2 of 1 over 4, because as you can see, it says 1 over b here. So that's 1 over 4 log 2 of n, which equals to 1/2 of log 2, because this here is also getting converted, and we get another 1 over 2 log 2n. Whoops. Okay. So essentially, okay, so now we have our rewritten equation. We can start simplifying and using the logarithmic rules. So first we can use a product rule to separate everything that's inside of the brackets. So that our equation would become log 2 of 1 over 4 plus log 2 of log 2n. Okay, and then our other side of the equation would become 1 over 2. I'm going to put brackets here because it might be a little confusing. Of log 2, 1 over 2. There as well. Plus log 2 of log 2n. Okay, so now that we've used the product rule on all of these, on all of the expressions, we can start simplifying again. So essentially this side of our equation stays the same, but we can work on this side first because there's a lot of stuff here compared to this side. So our equation would become log 2, 1 over 4 plus. Let me just write this side of the equation really quick. Okay, so here, we're gonna first work inside of the brackets. But essentially, like, these two 2's will cancel out, which leaves us with this 1 here. So that would actually give us 1 over 2 negative 1, because it's from a fraction, plus log 2 of log 2n. Okay, so now that we've simplified that, now we can work on this side of our equation. So next, we're gonna simplify this part. This would actually just equal to negative 2, because, like, once again, you're just simplifying and then taking it from the fraction, so it would be negative, and then you add, and then now we just add the rest of our equation. Negative 1 plus log 2. Okay, now that we've simplified some, we can start like shortening our equation. So first we can add 2 to both sides of our equation, of course, to get rid of this 2 here. So that would give us, that would make our equation negative. Oh my God. Yeah, that would make our equation, hold on. Okay, yeah, so that would make our equation, just log 2 of 2n equals to, 1 over 2 plus negative 1. Oops. So actually, and we can also remove the brackets. So from here, I forgot to add them back up here. And we can also remove the square brackets here. So that would give us 1 over 2 plus 1 over 2 log 2. Wait, sorry, I made a mistake here. Okay, first, before we add 2 to both sides of the equation, we're gonna remove the square brackets here. So our equation would actually be negative 2 plus log 2 log 2n equals 1 over 2 plus 1 over 2, because you're just essentially like multiplying everything by 1/2. This log 2 log 2n. Okay, so now that we've removed the square brackets from our right side of the equation, we can just now we can add 2 to both sides of the equation, which should give us 2 log 2n. And then sorry, I forgot something again. So essentially, we're also, but yeah, no, we're adding 2 to, yeah, we're adding 2, and then we're also subtracting 1/2 log n. So that actually leaves us with 1/2 log 2 log 2n, which is equal to 3/2. Because like we just got rid of this, and yeah, and then we subtracted another, yeah. So essentially, now that we have our equation here, it's pretty simplified already, we can just multiply everything by 2 to get rid of the denominators of the fractions, which just give us log 2 log 2 n equals to 3. So now that our equation is like this, we can actually just multiply everything. We can exponentiate everything by 2 again, which means this would cancel out. We can exponentiate everything by the base of 2 again, which would give us equals to 8, because we're exponentiating everything by the base of 2. So now our equation is that log 2 to the power log 2 base 2 of n is equal to 8. And that means that n is equal to 256, because 2 to the power of 8 is 256. So now that we've added the digits, so now we can add the digits of these together, which is 2 plus 5 plus 6, which gives us E13. So yeah, do you guys have like any questions about that solution? Okay, no questions. Okay. It's already like almost 1 p.m., so I can't explain any more questions, but I will do so the next time I teach because there's still like a lot of problems for me to explain.